Welcome viewers, in this video we will see the program to find the sum of the given series using the C programming language. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. So using the C program, we need to find the program 1, that is sum of series. We need to find the sum of the series. The given series is 1 plus 2 plus 3 plus up to n. Right, so it is increased by 1 by 1, 1 plus 1 2, 2 plus 1 3, like that up to n numbers. So we need to find the sum of this series. Now we'll open the main program, void main, open the braces. The header file we can include, is a default, we can include the header file stdio.h conio.h. Then we'll declare the variable integer n comma I comma sum. So the n is nothing but the maximum value in the series. Starting from 1, it will go up to n number. So this series can be formed by using the for loop. For that we are using this variable I. The answer is stored in sum. The final answer, the adding this series is stored in the sum. Right? So n is the maximum number in the series. I used for loop. In the answer is stored in the variable sum. After clear screen, we ask the user to enter the value of n. We need the value of n, right? So this user will enter the n value. Using the scanf, we can scan the n value, and n mean address of n. The user enter the n value stored in the variable n. Right. Now how to create this series 1 plus 2 plus 3 up to n? Using the for loop. We know that for loop having 3 variables: initial value, condition, increment. What is the initial value? We need to specify here. What is the increment? What is the next number? What is the condition up to which we need to go? Right? From this series we can easily decide. Initial value is 1. Right? Initial value is 1. What is the increment? It is incremented by 1 by 1. 1 plus 1, 2, 2 plus 1, 3. So I plus plus. I plus plus mean what is the meaning? I equal to I plus 1. With that I value 1 will be added. I equal to I plus 1. Right. Then what is the condition? Condition is up to n. Right. I less than or equal to n. N also included. So less than or equal to n. So we open the for loop. For I equal to 1, I less than or equal to n, I plus plus. 1 is the initial value, n is the maximum value, incremented by 1, 1. So that I equal to 1, I less than or equal to n, I equal to I plus 1. That is I plus plus. So this for loop will create the number starting from 1, 2, 3 up to n. Now we need to add this number. In order to get the answer, we need to add this number. For that, what we are using sum equal to sum plus I. We'll see how it will add at this value. We'll take this initially sum equal to 0. We assume that initially sum equal to 0. Then only the memory buffer will be cleared. What we are adding the number will be added into the sum. So that we are clearing the memory sum equal to 0. So what is the initial value? I equal to 1. First the I value is 1. Right? So it will go to the statement. The I is less than or equal to n. Let us consider the n what we entered is 5. We can go up to 5. So this condition is satisfied. It will go to the statement. Sum, what is the statement? Sum equal to sum plus I. The sum is 0. I is 1. So 0 plus 1, 1. Now the sum value will be 1. Initially sum value is 0. After executing this statement one time, sum equal to sum plus I, sum equal to 0, I is 1 means 0 plus 1, it become 1. Then it will go to the increment, I plus plus. That is I equal to I plus 1. Means I is already 1, 1 plus 1 it become 2, I equal to 2. This condition is satisfied. I is less than or equal to n. N is 5, I is now 2 only. So this condition is satisfied. Again it will execute sum equal to sum plus I. The sum is now 1. I is 2. So 1 plus 2, 3. right? Now the sum become 3. Again it will go to the increment. Like that it will go up to 5. For example, if we enter 5, it will go up to 5. So after executing all this up to this condition, the sum is added with I. So finally we will get the final answer. So printf, the added value is %d sum. So it will give the final value. So after get ch, we can close the program. Right. Now we'll see the output. Let us consider this n equal to 5. Right. So initially I equal to 0, sum initially I equal to 1, sum equal to 0. So sum equal to sum plus I. That is 0 plus 1, it become 1. Now I equal to 2. So this condition is satisfied. So that sum equal to sum plus I. So the sum value is now 1. So 1 plus 2, it become 3. Right. Now I become 3 incremented. This condition is satisfied. I is less than or equal to 5. So that sum equal to sum plus I. Sum is now 3. 3 plus now I also 3. 3 plus 3, 6. Now I equal to 4. Incremented to 4. Sum equal to sum plus I. Now the sum value is 6. So 6 plus 4 equal to 10. Again I equal to 5. Now sum equal to sum plus I. The sum value is now 10. 10 plus 5, 15. Right. Now I equal to 6. So this condition is not satisfied because n equal to 5. We entered n equal to 5. Now I equal to 6 means I less than or equal to n. The I is 6 now. So this condition is not satisfied. Right. So it will stop the process. The for loop will stop the process. So it will execute it up to this. See, the sum value is 15. Now we will verify that. 1 plus 2 plus 3 plus 4 plus 5. Right. So 1 plus 2, 3. 3 plus 3, 6. 6 plus 4, 10. 10 plus 5, 15. So this is our required answer. So we got the required answer. Right. So starting from we entered n equal to 5. I value is 1. How is it we decided I is equal to 1? It is clearly given in the series. I equal to 1. Suppose series starts with 2 means I should be 2. The answer is stored in sum. So we cleared the memory by putting sum equal to 0. We assign 0 value. Then sum equal to sum plus I. This means the sum and I will be added and that is stored in the sum itself. That is the advantage of this expression. Sum equal to sum plus I. Added and stored in the sum itself. So the sum value will be updated here automatically. Initially sum equal to 0, I equal to 1. So 0 plus 1, 1. That 1 is stored in the sum. The sum is keep on updated. Initially 0, now 1. Then it will go to I equal to 2, 3, 4, 5 like that. Up to it will go 5. While going to 6, the condition is not satisfied. It will stop the process. So that we got the value of 15. So in this program, we discuss how to add the sum of the series. By using for loop, we are performing this operation. In that for loop, we have 3 conditions, 3 statements: initial value, final value, and the increment. Initial value easily identify from the series. Condition we can easily identify from the series, that is n. The increment is, see the series, it is incremented by 1 by 1. So that I equal to I plus 1, I plus plus. So I equal to 1, I plus plus is the increment, I less than or equal to n is the condition. So using for loop, we executed this program. And the expression is sum equal to sum plus I. That is sum and I is added and stored in the sum itself. So we discussed the sum of series program using the C language. Similarly, we can have so many other series also we can perform using the for loop. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we will see the program to find factorial of n number using the C programming language. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, program to find factorial of n number using the C language. What is the factorial of n? It is nothing but multiplication. 1 into 2 into 3 into up to n. What is the number what we need? Factorial of 5 means up to 5. N means up to n. Right? So 1 into 2 into 3. So by series it is going 1, 2, 3 up to n number. We have to multiply. Right? That is called a factorial. Normally it is represented by n factorial. For example, 3 factorial means 1 into 2 into 3. That is 1 into 2 plus 3, 6 is the answer. Right? So this is called a factorial. This is represented by this symbol n factorial. Right. Now we'll go to the program. Void main, open the braces. The header files we need to include by default. Header include stdio.h, console.io.h. Right. Now we'll go to the declaring the variable. Here integer n. N is nothing but the number what we need to find the factorial. This I is used for loop. So this number 1, 2, 3, 4 up to n will be created using, we are going to use the for loop. For that we are using I equal to I variable. Then fact equal to 1. So if you assign 1 into the factor, the memory will be cleared. 1 will be stored in the factorial. Normally 0 will be assigned, but here we are doing the multiplication. If you put 0, the entire value will be 0. So that we are putting fact equal to 1. For example, sum of series means sum equal to 0. In that we can add the value. But here sum of series means addition. So 0 plus value will not affected. But here we are going to perform multiplication. So that fact equal to 1. Then after clear screen, we ask the user to enter the n value. For which number we need a factorial. User will enter the number using scan of %d and n. The number will be stored in address of n, and n means address of n. Right. Now the user enter the n value that is stored in variable n. Now we need to open the for loop. There is semicolon not available. For loop. For loop having 3 statements: initial value, condition, increment. Right. What is the initial value? From here we can easily identify. Initial value is 1, not 0. Initial value is 1. What is the condition? We can go up to n value. So I less than or equal to n. What is the increment? It is incremented by 1 by 1. So I plus plus. I plus plus mean what is the meaning? I equal to I plus 1. With the value 1 is added. That is in a simplified form we wrote I plus plus. Right. Now we open the for loop. Initial value is 1. Final value is n. The condition is n. It is incremented by 1 by 1. I plus plus. So I equal to 1. I less than or equal to n. I plus plus. These are all decided from this series factorial. Initial value incremented by 1. This is the final value condition. And what is the expression available here? Fact equal to fact into I. Sum of series mean will be added. Factorial it is multiplied. Fact equal to fact into I. Right. Now we will see the exam. I will see how it will be worked out. So initially the fact value is 1. We already assigned that fact value is 1. The I value also 1. Right. Initial value of I is 1. So I equal to 1. What we are executing? Fact equal to fact into I. Factorial value is 1 and I value also 1. So 1 into 1 will get 1. Right. Then it will go to the increment I plus plus. So that I value will become 2. I equal to 1 plus 1 means it become 2. Again it will execute this condition. Right. Because this let us take it is 3. The entered n value is 3. So I equal to 2 mean it is condition is satisfied. 2 less than or equal to n. This condition is satisfied. So again this statement will be executed. What is that? Fact equal to fact into I. The factorial value is now 1, but I value is 2. It is incremental. So 1 into 2, 2. See this, now the factorial value become 2. Then again it will go for the increment I plus plus. So that I become 3. Right. So I is 3, n is also 3. So this condition is satisfied. 3 less than or equal to 3. Equal is there. Right. Now also the condition is satisfied. So fact equal to fact into I. What is the factorial value? Is 3. I value is, factorial is 2. I value is 3. So 2 into 3, 6. Right? Now again the I will be incremented to 4. But this condition is not satisfied. 4 less than or equal to 3. We will go up to only 3 only. For the value of I equal to 4, the condition is not satisfied. So the loop is closed, terminated. Right? So what value we got is 6. Right? Now we will verify that the 3 factorial means this is available here. 3 factorial means 1 into 2 into 3. So 1 into 2, 2, 2 into 3, 6. So we got this value. So printf, the factorial of given number is percentage %d, that is available in fact, that is fact. The answer is printed, right? So by using for loop, we are generating this number. By using this expression, fact equal to fact into I, this the expression is, these two are multiplied, again it is stored in factorial. The factorial values keep on updated. Initially 1, after multiplying 1, after that 2, then become 6, right? So multiplied and stored in the variable itself. Now we'll see the another example for n 5 factorial, right? N equal to 5. We'll take one more example here, n equal to 3, right? So initially I equal to 1. What is the factorial value? Factorial equal to factorial into I. Factorial is 1, I also 1 initially. So 1 into 1, 1. Right? Then I become 2, of then incremented I equal to 2. What is that? Factorial equal to factorial into I. Factorial is 1, I is equal to 2 now. So 1 into 2, 2. Right? Then I become 3 because now the n value is 5. This condition is satisfied. For that, what is the factorial value? Factorial equal to factorial into I. Factorial value is 2. The I value is now 3. So 2 plus 3, 2 into 3, 6. Right. Now I become 4. What is the factorial value? Factorial equal to factorial into I. The factorial value is now 6. 6 into 4. 6 into 4, 24. Now I equal to 5. Right. So the factorial equal to factorial into I. Factorial value is now 24 into 5. That is equal to 120. Right. Now I become 6. See, this condition is not satisfied because n equal to 5 only. If the I is become 6 means this condition is not satisfied. I is less than or equal to 5, condition is false. So the for loop will be terminated. So up to I equal to 5 only it will be executed because we gave n equal to 5. See, this finally what we got is 120. The answer what we got? 120. That is 1 into 2 into 3 into 4 into 5. 1 into 2, 2. 2 into 3, 6. 6 into 4, 24. 24 into 5, 120. Right? So by using for loop, we are creating this number 1, 2, 3, 4, 5 like that up to condition. Then how we are multiplying? Using this factorial equal to factorial into I. Again that value is stored in the factorial itself. So the factorial value keep on updated. Initially 1, then become 2, then become 6, then become 24, then become 120. Keep on updated. This 120 is the final value. So in this video we discussed the program to find the factorial of n number using C programming language. Here we use the for loop to generate the number. We discussed the example also for the 5 factorial as well as 3 factorial. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the program to generate the Fibonacci series using C programming language. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Program to generate the Fibonacci series using the C programming. What is the Fibonacci series? It's nothing but 0, first number is 0, second number is 1. The third number is nothing but sum of previous two, 0 plus 1. Fourth number is nothing but previous 2, sum of previous 2. 1 plus 1, 2. 1 plus 2, 3. 2 plus 3, 5. 3 plus 5, 8. 5 plus 8, 13. 8 plus 13, 21. Like that it will go. So the number is sum of previous two numbers. That is the logic of the Fibonacci series. Let us consider the first number is 0, second number is 1, third number is nothing but sum of first and second number. After creating the third number, fourth number is nothing but sum of second and third number. That is nothing but the number is the sum of previous two numbers. Like that we need to generate. So let us consider A equal to 0, B equal to 1. We will assign A is 0, B equal to 1. What is C? C is nothing but A plus B. That is the logic of the Fibonacci series. The number is sum of previous two numbers. C is nothing but sum of previous two numbers. So A is 0, B equal to 1, C means A plus B. After finding this one, what we need to do? We need to shift the position. We will make this is number A. This one is number, this one is A, and this value, this number 1 is assigned as B. The value is shifted. Again C is nothing but A plus B. Right? So what we need to do is, after this, first is A 0, B is 1, C is nothing but A plus B. So that we got this value 0 plus 1, 1. Now we need to find the value of 2. For that we are shifting the value. That is, we are going to store the B value in A. That is A equal to B. What is the meaning? B value will be stored in A. Then B equal to C. C value will be stored in B. Right? Now A and B is shifted. Now A is 1, B is 1. Right? After executing this statement, the B value is stored in A, C value is stored in B, so that the position is shifted. Now A is 1, B is also 1. Again we can execute this. C equal to A plus B. What is A? Is 1. What is B? Also 1. So 1 plus 1, 2. So after then again we need to shift that. We need to make this is A, this is B, this number is B. So that C is nothing but A plus B. 1 plus 2, 3. So by using this statement we can shift the position. B is assigned to A, C is assigned to B, so that C equal to A plus B. So the position one by one it is shifted by using this statement. Then we can add this value. Right? So this is the logic behind the Fibonacci series. Now we'll go to the program void main. Include finds, by default we can include the header files. Include hash include stdio.h console.io.h. Standard input and console input header files need to be included. Now open the main program, open the brace, integer ABC. So we need the three variable ABC. First number, second number, third number is the sum of 2. Then I. In order to generate the for loop, by using for loop only we can perform this operation. So that we are having I. The term, how many terms are needed? Up to which number we need to generate the Fibonacci series. For example, 10 means the 10 numbers will be generated. The term is number of terms, not a n value, not this value. 10 means 10 numbers will be generated. Right? So A, B, C is the first three digits of this Fibonacci series. I is used for loop. Term is how many terms we need. That can be got from the user. So after clear screen, we ask the user to enter the number of terms. How many terms are needed? Scanf %d and terms. Address of term. The user what we entered is stored in that variable term. It is located in that particular address. Right. Now we got the number of terms. Right. So we need to assign this value. A equal to 0, B equal to 1. First two values are assigned. A equal to 0, B equal to 1. Then C also, we assigned as 0. Right. Now print of the Fibonacci series is. Right. First we will print the sentence. The first two values we can print as it is. Print of %d /t %d /t a comma b, because 0 and 1 is fixed. Only from third term only we are going for calculation. This slash t refers, it is a tab. So 0 is printed, after one tab 1 will be printed, right? So first two digits also now we printed. Now we'll go to the remaining terms, how to generate the remaining terms. So we created the for loop for I equal to 0, I less than or less than terms, because we started from 0, term 10 terms mean I less than term, I plus plus, right? So it is incremented by 1. So this loop, for example, if the term is 10, so this loop will be executed 10 times, starting from 0, 1, 2, 3 up to 9, because 10 is the condition is not satisfied. If it is 10 means I is 10 means condition not satisfied, the terminated, right? So I is initially 0, then 1, 2, 3, 4, 5, 6, 7, 8 and 9. 10 means that loop will be terminated, right? So this is a normal loop. So this loop is not related to the Fibonacci series. Fibonacci series is different. Just for repeating this process, we open this for loop, right? This for loop executed from 0 to 9 means 10 times, because the user enter 10 times. So it will be executed 10. So 10 times we can repeat this process, right? Now C equal to A plus B. That is our logic. The number is sum of previous two numbers, right? Then we print the third number. After printing, we need to exchange these numbers. B is stored in A, C is stored in B. Then we can go for the increment again. So the process will be repeated again and again, right? So we are after first one is the number is sum of previous two numbers. After printing, we are exchanging the number, so that again the number is sum of previous two numbers, right? Now we'll see the example, right? So now A equal to 0, B equal to 1. A is 0 and B is 1. That also we printed. 0 and 1 is printed with the tab, right? The term is, let us consider the term is 10. What is C? C equal to A plus B. So this is nothing but A, this is B, right? So 0 plus 1, it will become 1, right? Initially it is A, this is B, this is C. A is 0, B is 1, C equal to, C is nothing but A plus B 1. After adding and after printing this value, we are exchanging this value. B become A now. This become A. C become B, right? We changed the position. We shifted one position. Again it is incremented. I plus plus means it will go to the 2. Now what will happen inside? C equal to A plus B. So C is nothing but A plus. What is A? A is 1. B is also 1. So 1 plus 1, it will give 2, right? So that is C. So after printing, again it is shifted. This become A and this become B. This is C. So B is stored in A, C is stored in B. Then after increment again it will execute the same process. C equal to A plus B, right? What is A now? A is 1, B is 2. So 1 plus 2, 3, right? So again it will go to the next process after increment. It will go up to 10 terms, right? So now this 2 become A, 3 become B. The C is nothing but A plus B. 2 plus 3, 5. So like that it will go up to 10 terms, because we open the loop for the user. Let us consider the user enter the number of terms as 10. So the 10 terms will be printed. Already 2 terms are already available. So here the 10 terms will be there. So 10 plus 12, 10 plus 2, 12 terms will be printed, because 2 terms we already printed before opening the loop. A and B is printed. So apart from this, remaining 10 terms will be printed, right? So I think you are able to understand. So the process is, the number is the sum of first and second number is we assign. First number is 0, second number is 1. Third is nothing but sum of previous two. Fourth is nothing but sum of previous two. Like that will go. That is the Fibonacci series. So what we are making? A, B. First number A, second number B. Third number is A plus B. After that again we exchanged it. This number become A and this number become B. So that C is nothing but A plus B. So keep on, we are shifting the numbers. Then we perform the expression C equal to A plus B, then printed then and there. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the program to find whether the given number is prime number or not using the C programming language. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we'll go to the topic. Program to find whether the given number is prime number or not using the C programming. What is mean by prime number? The number divided by number itself. It's not divided by any other number is called a prime number. If you take one number, it will not divided by any other number. It is divided only by that number itself. That is called a prime number. So we have to check the number is given means we have to check the number divided by 1 we need to divide. If it's divided by any other number, we can decide it's not a prime number. It's not divided by any other number, it is a prime number. Right. We'll take one example. If you take 8, take the number 8. How to find the remainder if it is divided or not? By using the operator, percentage operator. So this divided operator will give the quotient. Percentage operator will give the remainder value. After divided, it will give the remainder value. Right. So this percentage operator used for is called a modulo division. Used for give the remainder value. This divider will give the quotient value. Right. Now we'll take the example 8, number 8. So we cannot divide by 1 because all the numbers are divided by 1 itself. So we can start with the number 2. Right. So we can start with the 2, 3, 4, 5, 6 up to 7. Right. We need to divide from 2 to 7. That is the number 8 is given. So we cannot start with 1. 1 is divided by all the numbers. So we can start with 2 and up to that number, before that number, up to 7. We cannot divide by 8 also. 8 divided by 8 itself. So we can stop up to 7. 2 to 7. From 2 to the number minus 1. That is 8 minus 1, 7. Right. So 8 percentage 2. What is the remainder? This 8 is divided 4 times. It goes, the remainder is 0. The remainder 0 mean what is the meaning? It is exactly divided. So it is not a prime number. If it is divided by any other number, it's not a prime number. Right. So we need to start from 2 to 7. We have to divide 1 by 1. First we need to divide by 2, 3, 4, 5, 6, 7. If any number is divided, we can stop the process. We can decide that that is not a prime number. So here it is divided by 2. So it is not a prime number. Now we can take the number 7. 7 percentage 2. 7 means we have to divide from 2 to 6. That is number 2 to n minus 1. 7 minus 1 up to 6. So first we will divide by 2. So while divide by 2, it goes 3 times. The remainder is 1. That means it is not exactly divided. 7 divided by 3. So it goes 2 times. 2 into 3, 6. The remainder is 1. That means it is not divided. It is not divided. The remainder is available. 7 percentage 4. That is equal to, it goes 1 time. The remainder is 3. That means not divided exactly. 7 percentage 5. So it goes 1 time. Remainder is 2. 5 into 1, 5. 5 minus 7 minus 5. Remainder 2. 7 divided by 6. It goes 1 time. 7, 6 1 time. The remainder is 1. So for all the number, it is not divided. The remainder is available. Remainder available means it is not divided exactly. Right. So it is not divided by 2, 3, 4, 5 as well as 6. We cannot go 7 because 7 divided by 7 is possible. Similarly, we cannot go with 1. All number is divided by 1. So we have to start from 2 only. We have to go up to 7 means 7 minus 1, 6. For all the cases, this is not divided. So this 7 is the prime number. We can decide 7 is the prime number. Right. So if it is divided, we can say it is not a prime number. We can stop the process. We no need to go to 3, 4, 7. We need to divide from 2 to 7. If it is divided by 2, no need to check with the 3, 4, 5, 6, 7. Once it is divided, we can stop the process and we can say it is not a prime number. If it is not divided, we have to go 1 by 1, 2, 3, 4, 6. For all the cases, if it is not divided, we can say the number 7 is the prime number. So this is the process to find whether it is prime number or not, right? Now we'll go to the program. So header files we need to include. It's not available here. By default we have to include the header file. Standard io.h, conio.h, standard input output dot header file, conio input dot output header file, right? Now we start with the main program. Void main, then open the braces, integer n is the number we are going to check, right? The number whether it is prime or not. We have to open the loop in order to create from 2 to 7 or 2 to 6. We need a for loop, right? So that for that we are using I. Flag, we are using one more variable flag equal to 0. Why? If it is divided, we can use the flag to identify whether it is divided or not. In this case, this is not divided. Here it is divided. Once it is divided, we can stop the process. So that flag is used to identify when it is divided, we can make this variable change. By changing this, we can easily identify. So initially it is 0. Flag equal to 0. So n is the number need to identify whether it is prime number or not. I is used for loop. Flag is used for indication. Then after clear screen, we ask the user to enter the positive number, right? So the user will enter, that is scanned by the scanf function %d and n means ampersand n, that is the address of n, right? The user what the number entered will store the location n, right? Now we can stop, now we can start the process for loop. So it is started with 2. For all the cases started with 2. We cannot start with 1, right? So it is started with 2. I less than or equal to n by 2. So n by 2 itself enough. No need to go. I already told it is no, it will go up to n minus 1. 8 means n minus 1 7, right? 7 means 8 minus 7 minus 1 6. But in this case it's not necessary. N divided by 2 itself enough. 7 means we can go up to 3, right? 8 means we can go up to 4 itself, because there itself it is divided, right? The division we can easily identify. No need to go up to n minus 1. N by 2 itself it is enough. Then I plus plus, because 2, 3, 4, 5 means I equal to I plus 1, right? So the initial value, we know that for loop having 3 statements. Initial value, condition, increment. Initial value is 2. Condition is we can go up to n minus 1, but n by 2, half of the number itself enough. Then increment is 1. I equal to I plus 1, that is I plus plus, right? Now this is the process. If n percentage I, right? N percentage I is double equal to 0. So n is the given number. This I is nothing but initially it is 0. For example, if it is 7, if you enter the number is 7 means the initial value of I is 2. So 7 percentage 2, that is equal to 0. But it's not equal to 0. The remainder is 1 is there, right? The remainder is 1. So it will go to the next process. If it is divided, then the remainder is 0. If the remainder is 0, for this case we will take this. The number is 8. Suppose the user enter the number 8, right? So here the number is 8. Percentage, initially the I value is 2. So 8 percentage 2 means it is 0. The remainder is 0. So we are checking that is equal to 0. So 0 is equal to 0. So this condition is satisfied. So what we need to, if it is divided, we can stop the process. They say that the number 8 is not a prime number. So that we can open one braces. We have the 2 statement. Flag equal to 1. What is flag value? Already it is 0, right? So always it is 0. If it is divided, any number divided, we immediately we can make it as flag is 1 and break the process. No need to continue, because once it is divided, 8 is divided by 2. We are not, no need to continue. No need to check with the 3, 4, 5, right? We can break the process, right? So if it is divided, the flag become 1 and break the process. If it is not divided, it will keep on check. For example, if it is 7, first it will divide by 2. In that case, remainder is there. Then divide by 3, because I will incremented. I become 3, then I become 4, 5. Right? This 2, 3, 4, 5 is incremented by the I value. In all the cases, it is not divided. Remainder is available. So this condition is not satisfied. So it will not go to this block. This is a true statement. This is not true in case of 7. So it will not go to this process. The entire loop got completed. So flag is 0. In case of 7, the flag value is 0. The flag is not equal to this 1. If it is divided, the flag become 1. If it is not divided by any number, the flag equal to 0. So by checking the flag value, we can easily identify if the flag is 0, the number is prime number. If the flag is 1, means there is not a prime number, because flag is become 1 only if it is divided and remainder is 0. In that case only the flag value become 1. So by checking the flag value, we can easily identify. Now we'll go to that, how to check the flag value. So after completing this process, we are checking after the for loop, and inside we have one more if loop, that are all closed. If flag equal to 0. So initially we set flag equal to 0. If it is 0, is mean the given number is a prime number. That means it is not goes to the inside of the if condition. So it is 0. If it is 1, else means, that means the flag become 1. When the flag become 1, any number is divided by exactly divided and remainder is 0, means the flag become 1. Right? So in this case, the given number is not a prime number. Right? So by checking the flag, if it is 0, the number is prime number. If it is not 0, means the given number is a not prime number. Then after get CH, we can close the program. Right? So in this video, we discuss how to find the given number is prime number or prime number or not. So by dividing the number, by finding the remainder, we can easily identify. If the remainder is 0, that means exactly divided. So that number is not a prime number. In that case, we make the flag equal to 1. If it is not divided by any number, that means there is no remainder. Remainder is not 0, always is available. In that case, the flag is equal to 0. What we initially gave flag equal to 0 is not changed. Thereafter, by checking the flag value, we decided whether the number is prime number or not. Flag is 0 means it's a prime number. Flag is 1 means it's not a prime number. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we'll see the how to reverse a number. Program to reverse a number using C programming language. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Program to reverse a given number using the C programming language. Let us consider the number n equal to 4589. We have to reverse the digits. That is 9854. 9854. We have to reverse the entire digit. Right? 4589 means it goes in a reverse order. 9854. Right? We have to reverse. This is the program. Right. Then how to reverse this? First what we need? First 4589 means we have to reverse at 9854. So we need a number 9. The last digit we need. So how to extract the last digit from this number? This is a given number 4589. So by using the modulo division. Modulo division means it will give the remainder. So it is divided by 10. After that it will give the remainder, so that we can get the last digit. Right? The division means it will give the quotient value. Modulo division means it will give the remainder value. So by extracting 9, if you divide by 10, it will give the remainder value. So 4589, if you divide by 10, it is 4580. 80 times it will go. The remainder value is 9. So that we can extract this 9 value. Right. Now how to multiply this? So we have one value. Initially it is 0. Because 9 means the next digit will be 98. So increase by 10. The next digit will be 5. Increase by 100. Next digit will be 4. Increased by 1000. So the position is keep on changes. This is the first position. Second position means 10 value. 3 position means 100 value, 1000 value. The position keep on changes. So that we are multiply by 10. So initially we kept as 0, right? We are having one value 0, that's multiplied by 10 plus 9. For that we are adding 9. So initially 0, so 0 into 10 0, 0 plus 9, we have the value 9. So this is the reverse number. We are getting the first digit now. I will go to the second and third digits, right? Now this 4589 we extracted the 9. Now we need to extract the 8. So we have to reduce this value. 4589 should be reduced to 4458. We have to reduce into 3 digits. Then only we can extract 8. For that what we are doing, it is divided by 10. Already we told divided by 10 means it will give modulo. This is the modulo division, this is the divider. Quotient will be there. So 4589 divided by 10 means it goes 4458 times. Right? So it gives the remainder. This gives the quotient value. Right? So first what we are doing, we are divide with the modulo division. We got the remainder. That remainder is added with one more value 0 into 10 plus that remainder value. Then the number is divided by 10 so that it is reduced to 3 digits. Now we have to repeat the same process. Now this number is available currently. So this number is divided by 10, modulo division by 10, so that we got 8, second digit we got. Now see this. This number is already available. 9 into 10 plus 8. So that it becomes 98. If we add 9 plus 8 becomes 17. But we have 9 is the first position, 8 is the second position. So that 9 is added, multiplied with 10, then 8 is added. So it becomes 98. Again is divided. 458 divided by 10 means it goes 45 times. Right? So that now 3 digits now changed to 2 digits. Right? Now we go to the next again. 45 percentage 10. So it is the remainder is 5 is available. Again 98 is there. 98 into 10 plus 5. Then only 985. It become 985. Then 45 by 10 it is 4. Now the 2 digit is now reduced to the single digit. Right? It is reduced to single digit. Now one more process is there. 4 percentage 10. The remainder is 4. It is not going. It is only remainder is 10. Already 985 is available. 985 into 10 plus 4. So 9854. This is our required answer. So as usual we have to divide by 10. So it is 0. It is not divided. Once it is 0, once it reaches 0, we can stop the process. Right? Until it reaches the 0, we can stop the process. Right? What we are doing first, we are finding the remainder value by divided by 10. That remainder is added with multiplied by 10. Again it is divided in order to reduce the digit. So this process is repeated until while dividing, if it reaches the 0 value, the process is stopped. Right? Now we'll see the program. So the main program, void main. So include file, header files you can include as default stdio.h, conio.h. Then integer n, the variable declaration. This is a number, given number. This is the revised number. This is the 4589 is the n. We need to find the reverse number, 9854. This is a remainder. We have one remainder value is there. So we have one more variable remainder. Right? So n is the given number. Reverse is the reversing the digit. It's the answer. Or storing the remainder, we have one variable remainder. After clear screen, we ask the user to enter the number. So user will enter the number using the scanf statement. The number is scanned and it is stored in and n, address of n. Right? It is available. The user what enter the number is available in n. Right? So initially the reverse is kept as 0. See this already initially it is 0. So reverse, this is the answer. Answer initially we kept as 0. Here we are using while loop. While n not equal to 0. Because while doing this process, when we need to stop, while dividing by 10, if it is 0, we can stop the process. If it is not equal to 0, we can continue the process. Right? So if it is not equal to 0, we can continue the process. So that while n not equal to 0, we can do this process. While n equal to 0 means we can stop the process. Right. What we need to do? Remainder equal to n percentage 10. That is the first process. You have to divide by 10 modulo division and find the remainder. So here remainder will be available. So the reverse equal to reverse into 10 plus remainder. We already said that reverse is already 0. 0 into 10 means 0 plus the reverse when the remainder will be added. This is the first process, remainder will be added. Then what we need to do? N equal to n by 10. This is divided by 10. So that 458 become 45. Right. So these three process we are doing inside the loop. First one, finding the remainder using modulo operator, then adding the value by multiply by 10, then only the digit will increase, then divide by 10 in order to reduce the digit. So these three process was done inside the loop. This process will be repeated until n become 0. If n is not equal to 0, the process will continue. Right. Now we'll take one simple example. 75. We'll take 75. We need to convert into 57. Right. We'll take this 2-digit value. Simple example. Right. What is the reverse? Reverse is 0. Initially reverse is 0. First finding, we are finding the remainder. Remainder equal to n. N is 57 percentage 10. What is the value? It will give 5. Right. The remainder 75 percentage 10 means it goes 7 times. The remainder is 5. What is the value available here? Reverse equal to reverse into 10 plus remainder. Right. Reverse is already 0 into 10 plus the remainder value is 5. That is equal to 5. Now the reverse number is 5. Right. Now what we need to do? We have to divide. Right. 75 divided by 10. So it become 7. Right. So this is the one process. We have to repeat the same process again. Right. We have to find that remainder equal to, this is a remainder, not as remainder. Remainder equal to 7 percentage 10. That is 7. It's not goes anytime. The remainder is 7. You have to perform this operation. Right. Now the reverse value is 5. 5 into 10 plus 7. So 57. So this is our required answer. What we got. Right. So again we need to divide. That 7 divided by 10 is 0. It's not going. If it is 0, we can stop the process. We got this answer and we can stop the process. Right. So this is one simple example. 57. 75 converted into 57. 75 first divided by 2. That is the remainder. We got 5. That 5 is added with the reverse. So that the reverse become 5. Initially 0. Then 75 is divided by 10. It becomes 7. Now 7 is given with the modulo division 10. So that it is 7. That is added with this expression. So it becomes 57. Is the required answer. The 7 is again divided by 10. It becomes 0. When it is 0, we can stop the process. This is our required answer. So that answer will be printed. The reversed number is percentage D REV. The answer is available in reverse. After get CH, we can close the program. So in this program, how to reverse a digit using C program we discussed. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we will see the program to find the Armstrong number using C programming language. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, program to find whether the given number is Armstrong number or not. What is Armstrong number? Sum of the cube of its digits, it's equal to the number itself. If the number is available, each and every digit, if you find the cube of that, by adding that all the cube, if the again the same number come, same number itself mean it is called a Armstrong number. For example, we can take 371. So the digits 371. Here the 3 digits are available. So 3 cube plus 7 cube plus 1 cube. If we add these 3, cube of digits is the cube of the digits is equal to the number itself. So the cube of digits are added. So it is 27 plus 343 plus 1, it is 371. The same number we are getting. So the digits are taking the cube, and if it is added, if we got the same number itself, is called a Armstrong number. Right. So what are the Armstrong numbers available up to 10,000? 0, 1, 153, 370, 371, 407, 1634, 8208, 9474 are the Armstrong numbers. Right. These are all the Armstrong numbers available up to 10,000. Now we'll see the process, how to find the Armstrong number or not. So 371, we'll take the number 371, right. So we need to take the 3 cube, 7 cube and 1 cube. We need to extract this digit one by one. How to extract this digit? For example, we can extract this digit 1 by using the modulo division. 371 percentage 10. What is the meaning modulo division? Division means it will give the remainder value. It will give the quotient value. Modulo division means it will give the remainder value. After dividing 371 by 10, the remainder is given. 371 after dividing 10, it is goes 337 times, the remainder is 1. So we got this digit. So by using the modulo division operator, we got the last digit. So that should be cube. We need to take the cube, 1 cube. So that 1 into 1 into 1. That should be added. All these three are added together. So that we are having one variable 0. In that we are adding this value. So 1 into 1 into 1 is 1. Right. So this process is completed. Now we need to find the 7. We need to extract the digit 7. So that this 371 is reduced to 37. How it is? By dividing by 10. 371 divided by 10, it will give 37. Now 3 digit is reduced to 2 digit. Now repeat the same process. Now we need to extract this 7. So use the modulo division 10. So 37 modulo division 10 means it goes 3 times, the remainder is 7. Right. So that remainder 7, we have to make a 7 cube, because 7 into 7 into 7. That should be added with the already available value, this 1. So 1 plus 7 into 7 into 7. That is 343. This is 343. With that 1 is added, 344. Right. Now that 37 should be reduced to single digit. So that we are dividing by 10. 37 divided by 10 means 3. Right. So what we are doing? First we are dividing the modulo division. By using modulo division, we divided by 10. Find the remainder. Remainder is cubed. Then added with the value. Second step. Third step is we are dividing by 10. So this is the process. Now we got this 3 value. Now we have to repeat the same process. So the same process repeated. 3 percentage 10 is not going anytime. The remainder is 10. We have to cube this value. 3 into 3 into 3. Already available value 344 is there. With that this 3 cube is added. So that we got 371. So this is our required answer. Right. Again what we need to, we have to divide by 10. 3 divided by 10, 0. Right. So once it is 0 reached, we can stop the process. So how to identify? We need to repeat these 3 processes. Modulo division by 10, then cube added, then divide by 10. So the process is repeated until it reaches the 0 value. So at that time we got the answer, so that if we got the 0, we can stop the process. Right. So we are doing 3 steps. Modulo division 10, adding cube, then divided by 10. If that while dividing it reaches 0, we can stop the process. Now we'll see the program. So the void main, open the braces, the header files we can include by default, stdio.h, conio.h. Then the variable declaration, integer n. This is a number, integer n. Then this is a n, number, num, in order to store the value. This is a remainder. Remainder will be stored in this variable remainder. Then sum equal to initially 0. After clear screen, we ask the user to enter the number to check the Armstrong number or not. Scan of %d n. Right. So this is the number. N number also we are storing this in order to check whether n and number is equal. So the copy of the number what we entered is stored in NUM, right? So this is the copy of the number what we entered. Initially we need to check so that this is the given number. This given number is stored in the another variable NUM also, right? So that we ask the user to enter the number what we need to check whether it is Armstrong number or not. That user will enter the number that is scanned by the scanf statement and it is stored in the n. It is AND ampersand n, right? Address of n. Now we'll see the next process. So the next step is num equal to n. The number is stored in the variable n. In order to finally we need to check this value so that number is stored in n. So while n is not equal to 0, so that is our final checkup. If it is reaches 0, we can stop the process. When it is not equal to 0, we can repeat this process. Remainder equal to n percentage 10. This is the first step what we are doing. So the remainder will be stored here. Sum equal to sum plus. So this process. Sum is initially 0. The remainder into remainder because cube of the value should be added, right? So in this the sum is initially 0. The first digit cube is taken, then it is added. In order to reduce the digit, we are divide by 10. So this is our 3 process. Modulo division by 10, adding the cube of the value and divide by 10. N equal to n divided by 10. Now the digit is reduced. The same process is repeated until when it is reaches the 0 value. Suppose if the remainder is 0, suppose the number becomes 0, that is we are using the n becomes 0, we can stop this process. When n not equal to 0, this process will be repeated. If it is 0, it will stop the process. So this value 371 is available in the variable sum because sum equal to sum plus remainder. We are keep on adding. Initially 0, first 1 cube is added, then 7 cube is added, then 3 cube is added. So that we have 371 available in the sum, right? Now we can stop this process when it is reaches 0 value, right? After that we need to check sum. Here the answer is available. The num, the entered value n is available in the num because now n is 0, so that the n is stored in another variable. So num equal to sum. If both are equal, mean the percentage d, that is the num is a Armstrong number, right? For example 371 means these two will be equal. So for some other number 200 or 300 mean these two are not equal, else the print of percentage d is a not a Armstrong number, right? So by checking these two values, this n is the given number, by dividing the n, keep on dividing, it becomes 0, so that the n is stored in another variable. So the 371 or entered number is available here. The answer what we calculated is available here. Both are equal, then we can say it is a Armstrong number. Otherwise it is not a Armstrong number. For example 370 or 371 means this value will be true. Any other number 155, 158 means this is not a Armstrong number, so that it will print it's not a Armstrong number, right? So in this program we discuss how to find whether the given number is Armstrong number or not. That is, Armstrong number is nothing but the cube of individual digits. While adding, it will give the same number itself. For example 371 means 3 cube plus 7 cube plus 1 cube, we are getting the same value, right? So by using that we have 3 processes. First to find the remainder, second one remainder is cubed and added with the variable, then divide the number in order to reduce the digit. The same process repeat until the number becomes 0. If it is becomes 0, we can stop the process. The given number is stored in num. Check with the answer. If it is both are same, it is a Armstrong number, otherwise not a Armstrong number. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.